Oxygen's discovery was a double-edged sword, nearly wiping out life on Earth 2.4 billion years ago. Around 2.4 billion years ago, oxygen-producing bacteria started to emerge, marking the beginning of the Great Oxygenation event. These microorganisms, known as cyanobacteria, were able to harness sunlight to split water into oxygen and hydrogen. As they multiplied and spread across the planet, oxygen levels began to rise, transforming the Earth's atmosphere. The problem was, this oxygen was toxic to the anaerobic life forms that had thrived in the absence of oxygen. These ancient organisms, which included single-celled microbes and complex multicellular organisms, were unable to cope with the sudden introduction of oxygen, paving the way for a mass extinction event that would change the course of life on Earth forever. Imagine a world where the very air we breathe is a toxic poison. This was the reality 2.4 billion years ago, when oxygen-producing bacteria suddenly dominated the planet's ecosystem. The oxygen they produced reacted with the methane in the atmosphere, forming a potent greenhouse gas called formaldehyde. This reaction was a catalyst for a chain of events that would ultimately lead to the Snowball Earth Ice Age. The buildup of formaldehyde trapped heat in the atmosphere, causing global temperatures to skyrocket. As the oceans warmed, methane hydrates, icy deposits of methane on the seafloor, began to melt, releasing massive amounts of methane into the atmosphere. This created a feedback loop where the increased levels of methane further accelerated global warming. The result was a runaway greenhouse effect, which would eventually cover the entire planet in a thick layer of ice, plunging the Earth into a deep freeze that lasted for 300 million years. This catastrophic event, triggered by the interaction between oxygen and methane, was a turning point in Earth's history, shaping the course of life on our planet in ways we're still trying to understand today. The key takeaway is that oxygen, while essential for life as we know it, was initially a poison that nearly wiped out all life on Earth. Surviving the Ice Age, life's resilience in the face of adversity. While the Snowball Earth event presented an enormous challenge, life found ways to adapt and cope with the extreme conditions. One example of this resilience can be seen in the evolution of primitive multicellular organisms, such as cyanobacteria and their close relatives. These microorganisms developed complex associations with other life forms, including single-celled organisms and early archaea, forming symbiotic relationships that enabled them to survive in environments that would have otherwise been inhospitable. For instance, some cyanobacteria formed partnerships with early eukaryotic cells, providing them with essential nutrients in exchange for protection and other benefits. These partnerships allowed certain life forms to not only survive, but even thrive during the prolonged Ice Age, paving the way for the eventual diversification of life on Earth. This early resilience and adaptability played a crucial role in shaping the planet's ecosystems, ultimately contributing to the emergence of modern life forms. The oxygen extinction may seem like a distant memory, but its legacy continues to influence life on Earth. One of the most significant outcomes was the rise of photosynthesis, a process that allowed plants to harness the very oxygen that once threatened their existence. This led to the development of complex ecosystems, as oxygen became a staple in Earth's atmosphere. The oxygenation of the planet paved the way for the evolution of more complex life forms, including the emergence of multicellular organisms and, eventually, the rise of intelligent life. In a strange twist, the deadly oxygen-methane reaction that nearly wiped out life 2.4 billion years ago also laid the groundwork for the diverse array of life we see today. The oxygen extinction serves as a poignant reminder that even the most catastrophic events can have far-reaching consequences that shape the course of evolution. Today, we breathe oxygen without a second thought, but this essential component of life was once a harbinger of death, a sobering lesson in the ever-unpredictable dance between life and its environment. So, as we conclude our journey through the oxygen extinction, let's recap. Oxygen's introduction was a double-edged sword that nearly eradicated life on Earth 2.4 billion years ago, and its lingering effects continue to influence our planet's ecosystems. This pivotal event transformed life's trajectory, ultimately paving the way for the diverse world we see today. Remember, life is incredibly resilient.